Hey guys, welcome to Unit 6, Lesson 2. This is going to be where we multiply rational expressions. It's going to be using a lot of the exact same ideas that we did in the first lesson. So like example 1 here, we're practicing factoring again. I know factoring doesn't go away. So this we would do double parenthesis. We would get, since it's x squared plus 5x minus 6, we get x and x. Factors of 6 that have a difference of 5. Since we have a minus sign after the 6, we know we get a plus and a minus. So this is actually going to be positive 6, negative 1. The next one here, do another set of double parentheses. X and x, signs are the same, both negative. So x minus, x minus. Factors of 2 that combine to make 3 are 2 and 1. And then the last one, now notice we only have 2 terms here. And with this one, all we are able to do is factor out a greatest common factor, which would be 3 and x. And then when you take a 3x out of both of those, you're left with 4x plus 3. And that's as far as we can factor that. All right, now these problems are like what we were practicing not yesterday, but in the previous video. So 4x squared over 4x cubed plus 12x. What you want to do for this one is leave the top by itself since it's a single term. We're not going to have a GCF of anything because there's only one term on the top. But the bottom, what can you take out of both of those terms? Well, you can take a 4 and an x, and then you're left with x squared plus 3. Now, if you notice, we have 4x squared on the top, and we have a 4x that we can take out. So the 4's are going to go away. And then a single x from the top and bottom is going to go away. So what we're going to be left with is x on the top, x squared plus 3 on the bottom. And you can't factor out x squared plus 3, so this is as far as we can take that one. The next one, x squared minus 5x minus 6 over x squared minus 1. So what can you factor out of the top? Try and do double parenthesis, x and x. So factors of 6 that have a difference of 5. So we know we're going to get a plus and a minus. And 6 and 1 have a difference of 5. It's going to be minus 6, positive 1, since it's a negative 5. And then the bottom, that's a difference of 2 squares. So that's going to be x plus 1, x minus 1. And now it works out conveniently that we have an x plus 1 on the top and the bottom, which leaves us with x minus 6 over x minus 1. And that's as far as we can take that one. All right. Now, this is the first new idea. It's when you multiply the rational expressions. So basically, we have 2 rational expressions, 2 factors that have numbers and variables. And if you recall, when you multiply fractions, you multiply the top times the top, bottom times the bottom. 3x squared times 25. So you multiply the numbers. So 3 times 25 is 75. And then we get x squared next to it. The bottom, you do 5 times 9, which is 45. And then you get x times y, which is xy. Now what we want to do is look for common factors. So 75 and 45, if you think about those two, one number that hopefully stands out to you right away is the number 5. If you take 75 divided by 5, you're going to get you're not going to get 25. You're going to get 15. We'll keep the x squared there as it is. And then if you divide 45 by 5, you get 9. And then x and y, we'll just keep those the same. We can keep reducing this. Now the next thing is 15 and 9 have a common factor of 3. If you divide a 3 out of 15, you're going to get 5. 9, you're going to get 3. The other thing we can do at the same time is, notice there's one x on the bottom, so we can cross out that x and then get rid of one of the x's on top. So we end up getting 5x over 3, and then there's nothing to cross out with the y. This is as simple as we can go, because there's no more x's and y's on the top and the bottom, and 5 and 3 don't have any more common factors. All right, let's do some more examples with these, and then you'll have a couple to try on your own. So example 4, multiply the rational expression here. So again, I like to start with the numbers on top. 6 times 10 is 60. And now when you multiply x squared with x cubed, since we can multiply those, remember the trick is you just add the exponents. So it becomes x to the 5th, and then the y's become 3 plus 4 is 7. Do the same thing on the bottom. Do the numbers together. 2 times 18 is 36. X squared doesn't pair up with anything, so it stays as x squared. But we do have y squared times y squared, which gives us y to the 4th. Now, look at the numbers first. What can you take out? 60 and 36. This one is a little bit tougher, but if you recognize it right away, you can take a 12 out of both of these. So 60 divided by 12 would give you a 5, and 36 divided by 12 would give you a 3. We have 2 x's on the bottom and 5 on the top, so if you subtract those, because we're dividing, we're left with 3. 5 minus 2 is 3, so x to the 3rd. I forgot to put the 3 down here. And then we have y to the 7th over y to the 4th. So since we have more on the top, we're going to have 3 left when we get rid of those y's on the bottom. You just subtract the number there. So this is going to be our final answer. 5x cubed, y cubed, all over 3. And you know you're done because you can't factor anything else out of the top or the bottom. Excuse me. This one, go ahead and multiply the top. You have to be careful. Think of this like it's in parentheses because you're multiplying everything on the top together with the other side. So since we're multiplying by 1, it doesn't change it. We get 5x squared minus 45. But the bottom, we do have to think of this like it's parentheses, and we have to distribute it. So x times 4x is going to give us 4x squared. X times negative 12 is minus 12x. 3 times 4x is plus 12x. And then 3 times negative 12 is minus 36. Now, simplify as much as you can. And we can actually factor out the top. Notice that we can take a 5 out of both of those, and we get x squared minus 9. And then the bottom, these are going to go away, and we're going to get 4x squared minus 36. We want to keep factoring as much as possible. I'm just going to keep going along here so I have enough room. We get 5x squared minus 9 factors to x plus 3, x minus 3. We really have to use those factoring skills, so be on the lookout for that. And then we have 4x squared minus 36. You can take a 4 out of those, and you're left with x squared minus 9, which we just said factors into x plus 3 and x minus 3. So since we have the x plus 3 and the x minus 3 on the top and the bottom, you can cross those off. And we're actually just left with 5 over 4. A lot of the times, these are going to reduce down to be pretty simple fractions like what we see here. Okay, a couple more. Now, this one, I would actually, but don't multiply it all out here. That is not going to help us. What we can actually do is factor before we multiply. So this first one, if you look here, 3x minus 27x cubed. So if we factor that, we can take a 3x out. We're left with 1 minus 9x squared. Okay. The bottom one, however, is a little bit trickier because we have a 3 out front. For this one, what we're actually going to do is we're going to go back to that box method. So if you recall the box method, we start by doing this cross section. We're going to have to do this a couple times. So I'm doing this bottom fraction here. So it is a times c. So 3 times negative 1 is negative 3 over the bottom is going to be negative 2. So factors of negative 3 that add to make negative 2. It's going to be minus 3 and positive 1. After we do that, we make our little box here. In the first box, we put our 3x squared. The last box, we put minus 1. And then these go into the other two. It's minus 3x and 1x. All right, going up and down, these two, we find the greatest common factor, which is 3x. Going up and down, same thing. we can only take a 1 out of those. And we go left to right. 3x squared and 1x, we can take an x out. And then negative 3x, negative 1, we can take a minus 1 out. So this actually factors into 3x plus 1. And then, oh, not 3. The other side is x minus 1. So there's our factors there. Now we got to do the same thing with this one. 3x squared minus 4x plus 1. So we would do that box method again. And I'll show you because it's been a while since we've had to do this. Do the cross section. A times c. This is our b. So a times c is going to be 3. And then the middle is negative 4. So factors of 3 that combine to make negative 4 are going to be negative 3 and negative 1. That one's a little tricky. So we do our box here. I want to make sure we can see this. We get 3x squared, 1, negative 3x, and negative 1. Now we do have to be careful because notice this is a positive one, but both of these are negatives, which means that we're going to get a minus sign both times. So 3x squared and negative 3x, we can take out a 3x, and then negative 1 and 1, we can only take out a 1. But like I said, we're going to have a minus sign for both of these. And then going left to right, 3x squared, negative 1, we can take out, oh, I forgot the x there. That should just be an x. And then negative 3x and 1 is going to be 1, but it's going to be a minus 1. So this factors into 3x minus 1 and x minus 1. And then the very last part here, this 3x, can't take anything out there, so we're going to leave that. Now, we know that when we multiply these things together, the bottoms are going to join, the tops are going to join. So let's just think of this as one big fraction as it already is. So what we do is notice there's a 3x here we're multiplying with, so we can cross that out with this 3x. There's a 3x plus 1 here that we can take out. Oh, never mind. Let me backtrack there. I can't take it out with the 3x minus 1. Those are different. We can take out the x minus 1. It's actually this part that's going to factor more. That's another difference of squares, and that's going to factor into 1 plus 3x and 1 minus 3x. 1 plus 3x is actually the same as 3x plus 1. We can change the order since they're both positive. So now that's going to cross out with that. And the only things that we actually have left is the 1 minus 3x and the 3x minus 1. Those are both on the top, so we're actually going to end up multiplying those. I know this is a really complicated problem. So multiply. We've got to FOIL it out. We get 3x, negative 1. Negative 3x times 3x is minus 9x squared. And then negative 3x times negative 1 is positive 3x. So what we end up getting here, I'm going to move the negative 9x squared to the front. These 3x's we can just add together, give us 6x, and then the negative 1 is all that's left. So now we have it in standard form. All right, next one here, x plus 2 over 2x cubed plus 8 times 9x squared minus 6x plus 4. This one, what we have to remember is x plus 2, that's fine as it is. This part here is going to be that a cubed plus b cubed, which is a special pattern. If you remember that pattern, I'm going to write it down here. A plus b, a squared minus ab plus b squared. Okay, so that's the pattern. And a and b in this case are going to be a equals 3x and b equals 2. Because 3x cubed gives us 27x cubed, and then we have the plus 8, which comes from 2. So I'm going to rewrite this because it's going to be kind of a big fraction. So now what we end up getting after I plug this in is 3x plus 2, and then the parentheses is going to be 9x squared minus 6x, 8 times b, so 3x times 2, plus 4. But now look at the other side. Remember, if it's just a single number like this, to make it a fraction, you just put it over 1. So now we have 9x squared minus 6x plus 4 all over 1. Now that we have one of these on the bottom and the top, we can actually cross out the whole thing. We don't have to worry about trying to factor or anything like that. So our final answer ends up being x plus 2, because that's all that's left on the top. And then we have 3x plus 2. Now don't lose points for this. That's as far as we can go. We can't factor anything more out of that. So, okay. Now, that might seem tough, but go ahead and give these few problems a try.